Hello YouTube, iFixItAll here, Team iFixItAll. We've got ourselves a 1954 CASCO iron. Model number N4. Steam iron. Add your water. It says it's made in Bridgeport, Connecticut. I don't expect anybody to be able to read this. Data is in here. I remember when I got out of boot camp, Mom gave me this to iron my clothes. And this was my iron. So it's been sitting in my workshop for quite a while. And I don't think it's ever been fired up since I last used it. I'm going to explore skinning this back a little bit so that you guys can see the construction of electrical back in that era. But what we've got here is a cloth covered cable. I wonder if this light will help any. And 2 conductors, I believe. Let me do some skinning and I'll try to see what I can expose. It's really nasty. I'm going to cut this end off here so we can start off fresh. And of course I have to use a 90-year-old pair of Swiss-made tin snips. Let's see what we got in there. Good God of mercy. Probably barely make out 2 conductors. Let's turn this big light on. Let's see what we can learn. I'm going to try to scar this cloth. Good God. Yeah, this is bad. So I just cut the cloth back, but even if that is, I think it was rubber coated conductors. Let me see. Yeah, it was some sort of coating on the individual conductors. Let me pull these fibers down. Pretty generous on the amount of conductors and the gauge, as far as the quantitative gauge of how many thin strands there are per run. Pretty generous. Looks like there's probably 35 or 40 strands of 40 gauge, maybe. I don't know. But the black the jacket around each conductor is just falling apart. So I'm replacing the cord. It's a real simple operation. However, I need to learn how to get inside this thing. So that's what the purpose of this video is to get the cord replaced. Hang tight. and I will see what I can do about scaring up a cord, because I'm going to have to find something robust. All right, so I was able to scare up something that looked like the conductors within were about the same diameter. Let me trim some of this back. Hang tight. So I'm trying to get rid of these fibers right here, the cloth. Trim that back so they're out of my way. Reason being is because I want to be able to measure the overall diameter of the individual conductors. So what I've done here is I've twisted one up, and I've looked up in my uglies electrical reference, looking for conductor properties. And there is a particular column called diameter in inches, so that's what I'm going to be using. And then it gives you the wire gauge in kc mil, circular millimeters. All right, so I'm going to go ahead and measure the diameter of the existing harness. Let's see what I come up with. Make sure I'm zeroed out. Make sure the jaws are free of any debris. Make sure it goes back to 0 exactly. All right. And I'm going to tighten up around this until I get friction. So we are there. There, that feels a lot better. So that's going to be 050.050. Starting to sound like a spark plug gap to some people. And I must have saved this cord back from something. Why do I have 3 ends? 3 ends. Hang on. I got a cord rolled up and there's 3 ends. Why? What's going on? All right. Got these razor blades from Amazon, and they're terrible. They are terrible. I even wrote a bad review on them. I think any shop needs to know, at least, if I can find it quick. Yeah. Do not buy these. If you see them at Amazon, don't buy these. All the razor blades are somewhat dull. I saved the container, though, because the container might be useful for something one day. I mean, does anyone out there know what a project box is? Might make a pretty neat little project box. So, with all distractions set aside, what in the hell have I done? Oh, 4 ends. I've got 2 cords. Okay. So, I would naturally be compelled to examine those cords first to verify the integrity. First, I want to find out which one is longer. They're about the equal length. So I'm going to check each one out to make sure I don't have any damages. because we're about to replace a cord that might need to hang out on this machine for many more decades. Unless, of course, in the future, nothing gets wrinkles. So the only flaw I see right out of the gate is this one is somewhat kinked off right here, and I don't know why, but I will choose not to use the one with a little bit of a smash in it. Kink in it. And I will pick this one, which means I have to strip it back a little bit to discover what the diameter is. This also happens to be a 2 conductor. When you do this sort of work, do a light scar, light etch, and bend the rubber over left to right, and then pull off, and you won't cut through. Aha, see, I went too deep. Look at the damage that you can do. I cut through the white conductor. Okay, so I'm going to discard that. I'm going to be more careful on my next go. This has a support strand in it. It's a nylon cord that's integrated into the insulation so that when you pull on these cords, these will act as strain reliefs for the whole cord in general. So let's see if I can lightly scar attempt number 2. There we go. There we go. It's snapping. Okay. That's good. I need my trash box over here. There we go. I don't know what that was. There we go. These are kind of paper covered nylon strands integrated into the cord. And here is your neutral, the white, and here's your hot, the black. So I'm going to trim the support strands back. Let me do some touch up here and I'll be right back. Get that cleaned up a little better. So our original cord was at 50 thousandths of an inch. According to the code, that told us that the original is going to be 050. It's probably going to be 16 gauge under conductor properties in the NEC. So every cable that's worth its salt will be stamped on it what is contained within. And I don't feel like hunting it down on this because I think this is the type of SO cord where it's actually molded into the rubber jacket itself, and this cord is so worn out it probably has worn off by now. I'm going to strip this back and see what I can measure to see what we can come up with. I'm stripping right now, starting with the number 14 gauge. Number 14. Just so I don't cut through and chop off any of these copper conductors. So, side-by-side comparison, it looks as though the copper conductor that is on the original versus the extension cord conductor right here, our extension cord conductor might be a little thicker, which is good. It's what we want. In this case, I don't want to be smaller. I'd rather be a little bit bigger. All right, so let's get the diameter up or twist this gently just so it maintains its form to act like it's a solid conductor. And we are zeroed. There's some junk on this in the way. There we go. And there's friction. And it is. It's 0.057. So it's a little thicker. So that's the wire I'm going to use. All right, with that being said, now it's time to dissect the iron. Shift some tools out of the way that are currently in our way. Do a little bit of cleanup here now that we've discovered what our circumstances are and what we're about to do. Now I need to figure out how to get into this beast. There are no screws on the exterior that I can see. How do I get in here to replace this cord? See, I got an interesting little thumb screw right here. And that looks like a little bit of a strain relief going on with a little metal washer. And a threaded nipple here. Looks like we've got a literal wedge anchor. It's like the keepers for a valve spring in your engine. And there's two of them. They're tapered. Very, very high quality. I can see how that works too. I'm going to turn this big lamp off. I don't know if it's going to help or hurt. Tapered. So I'll have to find me a parts container. Hang tight. Got me a little parts container. Get the uglies out of the way. We don't need that no more. This is very interesting. So now we know the cord goes down in there. Let's see if we can find any screws down in here. No? How in the hell does one get in there? Okay, so since I'm watching me study it, hang tight. Well, okay, so there's a single screw underneath this adjustment knob. Looks like I may have to keep that daggone light on unless I can turn this fluorescent on. I don't think this fluorescent's been ran in 90 years. I didn't help. Huh. Dang, LED light is so bright. All right. There's a single screw down underneath this knob. Nowadays, engineering, you would think automatically, let's just pry the knob off. And after some assumptions suddenly questioned, I studied the knob a little closer and spun it around, and wouldn't you know, there's an Allen screw in there. So let's get the right tool for the right job. Let's see if we can get lucky and go to our drawer of Allens. Looks pretty darn tiny to me. I think I'll just start with you. See what we come up with. Neat. No, that's too small. That was, I didn't think it would be that big. Could be. Huh. Let's see what we come up with here. There we go. That screw has not been out since 1954. Whoever put that in, I don't know why I think like that, but I'm like, somebody installed that. Here I am coming in behind them. All right, so so you can't just put that knob on willy-nilly. It needs to be adjusted. Let me see what I'm trying to say here. I better tighten that back down where it was and find out where off is so I can mark it. All right, so it's not keywayed, but I do see the witness mark of where it's been all these years. Do I need to know that? No, I can just put it right back on where the old witness mark is. All right, because this shaft is round, so this could be dropped on and put anywhere, but it has a on-off marker, and it also has heat indicators here with writing on it. It tells you how hot it is and what kind of fabric you're on. But the only thing I need to do is just make sure I install this knob the way it was on the old witness mark, which is made right into the shaft. You can see a little dimple on the brass shaft. Right there, it's a little black dot. Maybe it's showing up or just an imperfection. Well, I got that off of there. Get that out of the way. Get that out of the way. Knob goes in there. Let's see how hard it is to get to that screw, because that screw does not look very forgiving. But it is a real, true, bona fide, deep well flathead, which is very rare to find these days. They look like a half round cap instead of these flattened out flatheads. So I'm hunting for a particular screwdriver. Oh, I don't want that. That's not flathead. I think I'll give this one a try. Yeah. I think this is held together with one screw, meaning it has a lock on the nose and the bottom rolls up and catches a screw. Well, that was pretty forgiving. Do I have to take... How am I going to get that? How do I get that screw out without conflicting with... It almost feels like I need to take this off right now. Somehow. Could be wrong, but something's not acting right. I think I'm going to have a clearance problem. You zoom in and you guys can see what I'm talking about. There we go. It's drifting. I'm trying to get in right here. Maybe the screw comes out. The head is hitting this. I don't quite understand. How am I supposed to... Does it pop off? I wouldn't think they would have made anything that cheesy like that back then. It's on an axle right here. Does the screw... I don't know how to open this. I'm bumping into the plastic right here. Oh God, I'm zoomed in. Of course I am. Yeah, the screw head is bumping into this plastic. I need to figure something out. Hang tight. I don't have the damnedest clue what I'm doing. Not at all. I thought taking an iron apart would be a simple thing to do, but I got a trapped screw head here. No other signs of any kind of fasteners, except for this one mystery looking thing that sticks up right here, and it goes out in here to a opening in the plastic or Bakelite. that really just serves no purpose other than to be like maybe a steam escape port or something. Some sort of safety. Like, it's almost like it wants me to put a wrench on it. It's hexagonal. Let's see what happens. It's unscrewing. It's tight. Oh, it's loosening. Oh, I think something's happening. Oh, it's coming off to the base. I've never been in one of these before. I'm going to have to study the hell out of this. I don't even know what I'm looking at. It's like some sort of cutoff. Safety cutoff. Okay, part. There's a washer. It goes with that. What are we doing here? What are we doing? That screw back here is still haunting me. Seems like that's the thing that's holding me up. I'm getting somewhere. Are you kidding me? How do I get... Okay, so that screw is loose. It's no longer influencing anything. You're coming apart. I bet we all could agree that I could sacrifice this cord right now. Lob it off. No sense in fighting it. Goodbye, cord. We will need you for your wonderful parts you have, though. There was a washer on here, I saw it. Yep. It's down inside. There it is. Okay. We will tie you off like that so you don't get lost. And put you right here. So we can shove this stuff back inboard. There we go. Yep, there's that screw that was giving me trouble. It's the only screw that holds it down besides this steam pop-off valve. Maybe. And there's my two conductors coming in. Notice it has high temperature wrap on it right here. This rubber coating. This, yeah, I will probably repurpose that. It's also got cloth tape, like surgical tape. As I take this apart, I study it to say, okay, what do I need to duplicate when I put this new cord on? Because apparently they're protecting against tremendous amounts of heat being produced. So all of this heat insulation barrier material is in extremely good shape. It's still rubbery. What kind of material is that called? Silicon something. It's pretty amazing technology back for 1954. Stuff is real rubbery, heat resistant. Most of the time when you run across this application, it's going to be an asbestos type woven cloth material protecting the wire. And here are my two crimped conductors. There's my potentiometer. I think we're going to blow this thing out and clean it first. So that means I'll be firing up the air compressor. So I can't tell which one was hot and which one was neutral. Nor do I see a reason to say that it matters. Let me clean this up a little bit. Be right back. Okay, so I got that off of there. It came off. That screw was in the way and all that, but I'm looking at these connections here and I'm trying to trace out the power feed. And it appears to me like since my potentiometer is right here, there's a real high quality assembly of parts here. There's a stop tab right here where it bumps into a little finger. That it appears to me like this would be my power feed input into the potentiometer, and the potentiometer branches over and goes to this insulated porcelain heating element right here, travels through the base, comes back around, and through the base there's another porcelain insulator right here that is CAD welded. It's literally probably some of the first CAD welds that were ever done, or electrical welded, where you literally fuse two metals together with crimping pressure without actually doing arc welding. And that integrates this lug right here, which is the neutral. So that's my hot, comes into the potentiometer. And what is the potentiometer? Well, like a little elevator switch down in here. If you look down in this little hole right here, you'll see two contacts. I'm going to turn out the big light. It's really hurting my eyes. I don't know if this is going to work or not, whether we'll all be able to see it. Let me see if I can turn it. You can see it. How do I do this? Back with the big light again. All right. Get oriented. I want you to look down in there. And hopefully you can see contacts. Well, when I turn counterclockwise, there's no pressure on them, but there's two contacts. I'll try to pry them apart. There we go. Well, I'm pretty sure I can get in there with a piece of emery cloth and clean those contacts. So that's what's going to make this video part 2. I'm going to try to take this tank off. Maybe. Not sure, but I don't want to run this into like an hour-long video. It's already getting kind of heavy as it is, and I'll do a part 2 because right now I got to get outside and cut the rest of my grass before another storm waves through. Alrighty, guys. We'll see you till next time.